Number 1. Introduction. Mysteries of science that float in the cosmos. Have you ever gazed up at the night sky, feeling both a sense of wonder and a hint of smallness amid the vastness above, each twinkling star, like a question mark in the night, sparks curiosity about the mysteries science seeks to solve? These are not just idle musings, but profound questions echoing through the corridors of scientific inquiry. Throughout history and into our present day, scientists have ventured to understand the ungraspable truths of our universe, much like chasing whispers carried by the wind. These science mysteries, some hotly debated, others oddly tranquil, captivate our imaginations with their complexity and their vast potential to reshape our understanding of everything. Consider how puzzling it is to confront the notion that particles might exist in multiple states until observed, or that hidden realms might teem with life beyond our perception. These are the enigmas that dwell at the heart of scientific exploration, challenging our notions of reality and our place within it. Imagine standing at the shore of a great ocean of knowledge, with endless waves of questions lapping gently at your feet. Each mystery is a chance to journey deeper, beyond the horizon of the known world. So, why delve into these conundrums? Because in questioning what we think we know, we open doors to greater understanding, to leaps in technology, philosophy, and beyond. In their pursuit, we engage not in mere debate, but in the very essence of discovery, chasing the unknown not just for answers, but for the thrill of the quest itself. In the stillness of night, as you let these mysteries wash over you, consider that these are more than just riddles to solve. They are the very fuel for the flames of human curiosity, inviting you to ponder, to dream, to imagine. So, let your mind wander as we explore these mysteries together and discover what lies at the edge of knowledge and just beyond. Number 2. Schrödinger's cat, the quantum quandary. Imagine a cat comfortably nestled inside a snug box, seemingly ordinary, yet a silent mystery unfolds the moment you close the lid. Is the cat lazily stretching, or has it fallen into eternal slumber? Oddly enough, until you peek inside, the cat exists in a curious state of both, or neither. Welcome to the world of Schrödinger's cat. In simple terms, this is a thought experiment crafted by physicist Erwin Schrödinger to illustrate a puzzling aspect of quantum mechanics. It's like contemplating a coin spinning in the air, both heads and tails, until you reach out and capture it. In the quantum realm, particles can exist in multiple states, all at once, until observed. Delve into this deeper, and you encounter a peculiar universe where the very act of observation alters reality, like a magician whose trick depends not on sleight of hand, but on where your eyes land. Consider the following scenario: agreeing to bake a cake. You're both mixing and not mixing the batter until you actually roll up your sleeves and see flour on your hands. Now, zoom into an atomic scale, and you might find particles behaving just as whimsically, existing in superpositions, objects, both silent sentinels and bustling dancers in the dark. Why do we use this paradox? It beckons us to confront the limits of human intuition and our understanding of the universe as composed of concrete certainties. It pokes at the notion that reality isn't fixed, only settling when prodded by curious minds. In its cleverness, It reveals layers of complexity that invite and defy explanation. But beware, such musings can mislead. They risk oversimplifying complex quantum theories into captivating anecdotes, clouding comprehension with illusion. So how do you identify this paradox in action? Look for tales of dualities, narratives that speak of multiple possibilities, existing pre-observationa, telltale hallmark of quantum curiosity. In responding, hold on to both wonder and skepticism, for they are your guides through this maze of complexities. Allow data and rigorous inquiry to anchor your exploration, reminding yourself that embracing such mysteries propels scientific thought forward. Finally, take solace in the paradox of Schrödinger's cat, a reminder that not all is as it seems. As you rest beneath an infinite night sky, let it beckon you to ponder realities unseen and contemplate the enchantments of quantum realms. Number 3. The Fermi paradox. Where are all the aliens? Look up into a sky punctuated by stars, dazzling jewels scattered across a cosmic canvas. Amid this vastness, a question echoes in the curious human mind. With such a vast universe, where is everyone else? Welcome to the mystery of the Fermi paradox. In simple terms, the Fermi paradox grapples with the contradiction between the high probability of extraterrestrial life and the lack of evidence for or contact with such civilizations. It's akin to entering a lavishly decorated ballroom, hearing echoes of distant laughter, yet finding it silent and empty. Imagine sitting at a radio, tuning across frequencies, hearing only static, with billions of galaxies, countless stars, and innumerable planets. Simple math suggests we shouldn't be alone. Yet, where are our cosmic neighbors? Let's explore a couple of scenarios. Firstly, a fundamental question. Could life develop under hostile conditions, thriving perhaps in forms unimaginable to us, existing at such distances or technological levels that make contact either impossible or undesirable? Secondly, imagine civilizations reaching critical junctures, encountering obstacles that prevent them from reaching stars or communicating beyond. These might include unsustainable resource consumption or technological self-destruction. Sobering thought, reflecting on our own planet's challenges. People ponder the Fermi paradox as it challenges humanity's place in the universe, prompting introspective questions about life, technology, and the future of existence, demanding humility in our cosmic quest for understanding. But it also sows seeds of caution. Assumptions can mislead, leading to premature conclusions about isolation or diminished exploration vigor. It challenges us to scrutinize the very lenses through which we view the cosmos. To recognize this paradox, look to discussions bridging vast possibilities across space and time debates about life's rarity versus the universe's generosity, a duality of isolation and expanse. When responding, maintain a balance of openness and skepticism. Engage scientific methods and philosophical inquiry, carefully considering the limits of detection and the potential variety of life beyond human experience. As you let the enigma of the Fermi paradox wash over you, find solace in both the mystery and our ongoing quest to understand our place amid the stars, uniting all who seek connection beyond Earth's confines. Rest in the notion that every unanswered question propels us onward, exploring not just the stars, but the essence of life itself. Number 4. The simulation hypothesis. Is reality just a video game? Imagine waking up one morning, everything seeming usual, birds chirping, the day unfolding as always. But what if all you perceive is merely a program running? A code written not in ink, but in binary. Everything an intricate illusion? Welcome to the puzzling notion of the simulation hypothesis. Simply put, the simulation hypothesis suggests that all of reality might be an artificial simulation akin to an incredibly advanced video game created by some higher intelligence. It's like inhabiting a virtual realm, where every interaction and experience is rendered in vast and complex algorithms. Consider experiencing déjà vu, those eerie moments that feel like a glitch in existence. It's intriguing to ponder if they are mere disturbances in a simulated reality, hints at undercurrents of a universe animated by lines of code. Now, think about how video games immerse us in vivid worlds, where characters act autonomously, ecosystems shift, and interactions unfold. The hypothesis posits a similar scale, but infinitely more sophisticated, suggesting our own universe could be designed, curated, and observed. People entertain this hypothesis not just as a flight of speculative fancy, but for its ability to challenge established notions of consciousness, free will, and the nature of the universe. It proposes a grand stage where we are both actors and simulators, experiencing life within defined parameters. However, while it fascinates, the simulation hypothesis also cautions against absolving reality of its tangible veracity. For if every encounter and every feeling is digitally constructed, does it nullify authenticity? To recognize this hypothesis, seek pathways where digital mirrors reality debates, considering consciousness as computable, discussions where boundaries between actuality and virtuality blur as technology advances. Respond to the idea by balancing wonder with scientific inquiry, contemplate philosophical questions, engage with technological advancements, and question your perceptions, maintaining a healthy skepticism grounded in empirical evidence and experience. As you let the mystery of the simulation hypothesis infuse your thoughts, rest easy in the melding of wonder and awe, recognizing that whether organic or programmed, the essence of each moment remains cherished and real. May this journey inspire curiosity as you explore realms both real and imagined, navigating through a cosmic tapestry without definitive edges, seeking understanding in the intricate weave of existence. Number 5. The twin paradox, the strange world of relativity. Imagine gazing across a starry sky, contemplating the mysteries of time, and then pondering this unconventional question: what if a journey through space could make twins? Once indistinguishable, return unequal in age. This captivating puzzle introduces us to the world of the twin paradox. In simple terms, the twin paradox is a thought experiment based on Einstein's theory of relativity. It's like watching two parallel runners who start and finish at the same point, yet one seems to have aged more than the other. The paradox suggests that a twin traveling at nearly the speed of light, upon returning, would be younger than a sibling who remained stationary. Delve into it and witness the strange elasticity of time in the cosmos. High-speed travel results in time dilation, an effect where time literally stretches, a wrinkle in the fabric of reality that defies everyday perception. Visualize this scenario. One twin embarks on a journey to a distant star and back, traveling at incredible speeds. while the other stays on Earth. Paradoxically, despite similar beginnings, their storylines diverge upon reunion, with the spacefaring twin appearing as if they pressed pause on their personal clock. People find the twin paradox alluring as it challenges intuitive notions of time, suggesting it as a flexible dimension molded by relative motion. It beckons us to grasp what defies logical cohesion in common experience, intrigue that borders on the fantastical. However, while evocative, account for its potential to confound. Without context, such theoretical paradoxes can weave misconceptions about the nature of time, space, and reality, breeding more myth than understanding. To recognize and comprehend the twin paradox, search for dialogues capturing time's fluidity debates, merging velocity with aging discrepancies. Narratives where space and time weave a unique quilt beyond fixed frameworks. When engaging with this paradox, ground yourself in the scientific substance of relativity. Embrace questions without forsaking logic, cultivating curiosity, filled with the awe of cosmic expansiveness, tempered by empirical evidence. As the riddle of the twin paradox resonates within you, take comfort in the intertwined mysteries of time and space. Whether contemplating cosmic velocities or resting with the certainty of the moment, find joy in discovering what lies just beyond the familiar, captured within corridors of thought, where imagination dances alongside scientific discovery. Number 6. The butterfly effect. Chaos theory unleashed. Imagine standing in a tranquil garden, observing a butterfly flit gracefully from flower to flower, its gentle wings barely stirring the air. Yet, somewhere in this wondrous simplicity lies the potential to change the world. Welcome to the mesmerizing realm of the butterfly effect. In simple terms, the butterfly effect suggests that small, seemingly insignificant actions can lead to profound consequences across time and space. It's like throwing a pebble into a still pond, sending ripples that touch distant shores. Originating from chaos theory, this concept illustrates the interconnectedness of complex systems. Picture a weather system, a phenomenon filled with countless variables. The flutter of a butterfly's wings might alter air currents, eventually contributing to dramatic shifts in weather patterns. Of course, such examples dwell more in the poetic realm, yet they convey the sensitivity of systems to initial conditions. Now consider your own life, a kind word exchanged, a choice made, a path discovered at a crossroads. Each instance, a subtle agent that can unfold into transformative stories over time. Such are the echoes of the butterfly effect, resonating profoundly through human experience. People are drawn to this theory as it elegantly encapsulates the unpredictable nature of life and the universe. It invites contemplation about the roles we play and how modest gestures can sculpt extraordinary futures. It serves as a humbling reminder of interdependency, drawing attention to details often overlooked. Yet, contemplate mindfully. The butterfly effect embodies complexity that challenges straightforward cause and effect assumptions. Without nuance, it could breed an oversimplified view, making it crucial to navigate these waters thoughtfully. To recognize and interpret the butterfly effect, look for narratives acknowledging subtle initiations within expanded outcome mysteries, interweaving chaos with elegant webs of influence. When engaging, preserve a balance between fascination and scrutiny. Embrace the beauty in small beginnings, while not neglecting the critical factors shaping events, evolution, rooting your understanding within context, and learning from the unpredictable dance of chaos and order. As you ponder the butterfly effect's enigma, to find solace in a reality that reminds us of every action's potential significance. Rest knowing that even the gentlest whispers may craft the symphony of life, leaving ripples that transcend beyond our immediate awareness. Engage with these mysteries and embrace your place within the grand mosaic of existence, where chance and consequence endlessly waltz. Number 7. The Grandfather Paradox, Time Travel Conundrums. Imagine possessing a key to unlock the corridors of time, granting passage to the distant past or the unknown future. But within this all lies a puzzling dilemma. If you could journey back in time, what would happen if you altered events so drastically as to change your own existence? Welcome to the perplexing enigma of the Grandfather Paradox. In simple terms, the Grandfather Paradox is a thought experiment that asks, what would occur if you traveled back in time and prevented your grandfather from meeting your grandmother? In essence, it raises the conundrum: could you erase your own existence before ever being born? Think of it like a circle that loops endlessly, where the simplest disturbance unravels the threads connecting past and present. This paradox highlights the intricate possibility of influencing events so fundamentally that the timeline itself might fracture or endlessly rewind a knot in the fabric of reality that defies straightforward resolution. Journey through this thought experiment, and you're faced with a cascade of questions. Would altering the past create alternate timelines or new realities? Perhaps the very act of traveling back corresponds with forming a divergent path, leaving the traveler in an alternate version of history. People explore the Grandfather Paradox as it captivates with the romance of time travel and the philosophical implications of actions and consequences. It challenges our understanding of cause and effect, suggesting a non-linear tapestry where each thread holds the power to reshape narrative arcs and destinies. Yet, tread carefully when enchanted by such paradoxes. The allure of time travel may obscure the complexities of physics and the constraints posed by our current understanding of the universe. Without empirical evidence, these musings rest more within the realm of philosophical quandaries than scientific truths. To recognize and grasp the Grandfather Paradox, seek dialogue on the intricate dance of causality debates, envisioning scenarios where the edges of time loop and twist into uncharted territories. When engaging, embrace wonder with reason. Entertain imaginative scenarios while anchoring understanding in scientific foundations, aware that time's mysteries stretch beyond our present grasp and invite more questions than answers. As the intrigue of the Grandfather Paradox envelops you, find repose in pondering time's nature and its unfathomable depth. Whether an impossibility or a future route of exploration, this paradox beckons to dreamers and thinkers alike, nudging gently at the boundaries of possibility and igniting the spark of curiosity that blazes brightly across the ages. Number 8. Dark matter, the invisible skeleton of the universe. Imagine floating in the limitless expanse of space, surrounded by swirling galaxies and shimmering stars. Yet, amid this wondrous spectacle, a profound mystery lurks, an unseen force that silently governs the cosmos. Welcome to the elusive realm of dark matter. In simple terms, dark matter is a non-luminous substance thought to make up a significant portion of the universe's mass. It's like an invisible scaffold that shapes the structure of galaxies, binding them together in gravity's silent embrace. To conceptualize dark matter, picture a bustling city obscured by dense fog. You hear the hustle and bustle, see vague outlines of buildings shaping the skyline, yet the intricate architecture beneath remains hidden from view. Similarly, dark matter's presence reveals itself through gravitational effects it exerts, despite being invisible to telescopes. Consider the rotation of galaxies' graceful celestial ballets, rendered inexplicable by observable matter alone. The speed at which stars orbit suggests an unseen mass providing vital adhesive, strength dark matter lying mysteriously beyond the grasp of light. People delve into the study of dark matter due to its monumental implications for our understanding of the universe. It presents a cosmic puzzle, hinting at a universe more expansive and enigmatic than glimpsed purely through visible spectra. Its exploration serves as a beacon, leading scientists to deeper insights about fundamental forces and structures. However, in navigating its mysteries, recognize the challenges it presents. Dark matter evades direct detection, prompting alternative models and speculative theories. Such elusiveness demands humility and perseverance in scientific pursuit. To identify and contemplate dark matter, pursue discussions unveiling the universe's mass discrepancy S-talks, illustrating dark rivers through cosmic maps where mass outweighs light. When engaging, merge wonder with inquiry. Allow your imagination to soar while anchoring understanding in methodical exploration, knowing that each step closer reveals the artistry of the universe's hidden framework. As the mystery of dark matter unfurls before you, find solace in the dance of the seen and unseen. Though it evades direct capture, this invisible cornerstone beckons toward cosmological mysteries waiting to be unveiled, reminding you that the universe holds secrets etched within its very essence, poised for those daring to glimpse beyond the observable, where invisible wonders ignite endless curiosity. Number 9. Consciousness, the hard problem of self-awareness. Imagine waking from a dream, a moment where the swirling chaos of sleep gives way to the structured clarity of waking life. Within that transition lies a profound mysterion that echoes through the corridors of thought, the enigma of consciousness. In simple terms, consciousness is the state of being aware and able to experience thoughts and emotions. It's like a symphony of sensations, perceptions, and thoughts dancing through the mind, forming the intricate tapestry of experience that defines you. Dive deeper, and you encounter the hard problem of consciousness, a philosophical quandary that asks how subjective experiences arise from physical processes within the brain. It's akin to trying to explain how the taste of chocolate or the color red emerges from networks of neurons and synapses. Consider standing at the edge of a forest, feeling the rustle of leaves in the breeze, the scent of pine in the air, the warmth of sunlight on your skin. These are not just sensory inputs, but richly textured experiences, imbued with personal meaning, inviting you to ponder how such richness stems from biology's elegant machinery. People explore this hard problem as it probes the very nature of reality, identity, and existence. Consciousness challenges the notion that all phenomena are tangible or quantifiable, highlighting depths of understanding, yet untapped. However, in grappling with consciousness, tread carefully between insight and assumption. The gap between subjective experience and objective measurement remains vast, with explanations often straying into philosophical or metaphysical territories. To recognize and contemplate consciousness, engage with dialogues bridging neuroscience and philosophy discussions, questioning the boundaries between mind and matter, exploring the depths of awareness that illuminate the human condition. When engaging, nurture curiosity with thoughtful exploration. Embrace the mystery as a catalyst for discovery, rooted in scientific endeavor and philosophical reflection, aware that the quest for understanding might itself be transformative. As the mystery of consciousness envelops you, relish the opportunity to ponder its layers, those that define and connect us all in shared yet singular experiences. Find peace in knowing that even as answers remain elusive, the journey through self-awareness invites reflection and wisdom, guiding us through the indefinable realms where experience and existence converge, a testament to the wonder and complexity of life itself. Number 10. The measurement problem. Observing changes reality. Imagine being on the threshold of discovery, peering into the quantum realm, where the very act of observation draws back the veils of uncertainty. Yet, here lies a twist as you observe. Reality itself seems to shift and reshape. Welcome to the perplexing riddle of the measurement problem. In simple terms, the measurement problem in quantum mechanics refers to the way that observing a quantum system appears to collapse it from multiple possible states into a single outcome. It's like watching a magician perform a trick before the reveal. The outcome remains a mystery. As soon as you look, the possibilities narrow to one manifest reality. Consider Schrödinger's cat that is both alive and dead inside its box until you open the lid. This unsettling scenario illustrates how quantum entities exist in superposition, potentially in various states at once, until measurement forces them into a definitive state, much like an array of hidden cards, revealing one fate. Journey deeper, and you grapple with the uncertainty principle, the notion that measuring one property of a particle, such as position, inherently obscures its conjugate property, like momentum. Reality appears like grains of sand slipping through fingers, its essence elusive, yet profoundly affected by the touch of inquiry. People are drawn to the measurement problem as it challenges entrenched views of reality. It hints at a world influenced by perception, where boundaries between observer and observed blur, catapulting science into philosophy and existential reflection. Yet, navigating these waters requires careful footing. The measurement problem can lead to misinterpretations that confuse rather than illuminate. Without precision, such interpretations might undercut the coherence necessary for scientific progress. To recognize and appreciate the measurement problem, explore discussions that weave quantum mechanics with philosophical inquiry debates, probing how observation and reality influence one another, igniting curiosity about fundamental nature. When engaging, maintain balance between awe and inquiry. Embrace these mysteries as invitations to expand understanding, grounded in empirical study, while open to philosophical insight, inviting a reflective dialogue between science's enigmatic edges. As the enigma of the measurement problem enfolds you, take solace in the profound realization of interconnectedness. While atoms dance and particles weave unseen fabrics of possibility and manifestation, relish in the mystery that each observation carves from the tapestry of the unknown, highlighting the intimate dance between existence and consciousness that shapes the universe. Number 11. wave-particle duality, light-split personality. Imagine standing at the shore of a sunlit ocean, where waves glisten in the morning light. Yet, as you gaze, consider the intriguing notion that this radiant light, so familiar and constant, harbors a hidden complexity. Enter the realm of wave-particle duality, where light reveals its elusive, split personality. In simple terms, wave-particle duality is the concept that particles like photons exhibit both wave-like and particle-like properties. It's akin to watching a painter skillfully shift between brushes, adapting strokes to the canvas. Light, too, shifts its behavior based on how it's observed. Picture light streaming through a narrow slit, spreading out to create patterns, much like water ripples on a pond. This is light as a wave. Now envision photons impacting a sensitive camera sensor, appearing as distinct spots, tiny particles marking their presence. This duality suggests light can be both, at once or selectively, a curious blend that defies classical explanations. Consider the double-slit experimenter benchmark experiment, where light sent through two slits creates an interference pattern like waves, until observed closely, when the pattern collapses, revealing discrete impacts like particles. This phenomenon echoes a light that chooses its guise in response to our gaze. People are enchanted by wave-particle duality, as it challenges conventions and unveils layers of reality concealed beneath everyday perception. It invites a dance where certainty and ambiguity mingle, revealing the boundless intricacies shaping our understanding of nature. But journey carefully through this mystery. The allure of duality tempts oversimplification or misrepresentation, wherein the subtleties of quantum mechanics are glossed over for compelling yet incomplete narratives. To recognize wave-particle duality, explore dialogues weaving together debates on light's dual characters, discussions where photons play dual roles across quantum landscapes, highlighting an elegant interplay of dual attributes. When engaging, blend wonder with rigor. Let your imagination soar while remaining grounded in empirical research, cultivating insight from both scientific endeavors and philosophical musings. As the enigma of wave-particle duality unfolds before you, find serenity in the coexistence of opposites. This phenomenon reflects a cosmic ballet, where light's dual nature unites to illuminate paths of understanding. Embrace these mysteries as humble guides through realms where conventional wisdom dances with the unknown, reminding us all that the light-guiding exploration is itself a profound paradox, igniting curiosity and contemplation. Number 12. Quantum entanglement. Spooky action at a distance. Imagine two particles dancing together in the silence of the quantum world. No matter how far apart they travel, a mysterious thread seems to tie their fates together. Welcome to the bewildering phenomenon of quantum entanglement, famously dubbed spooky action at a distance by Einstein himself. In simple terms, quantum entanglement occurs when pairs of particles become linked in such a way that the state of one instantaneously influences the state of the other, regardless of the distance separating them. It's like a pair of dancers who perfectly mirror each other's steps, whether they find themselves in a crowded ballroom or miles apart in different rooms. Consider flipping a pair of entangled coins. Even if one is on Earth and the other on a distant star, the moment you observe the earthbound coin be it heads or tails, the other coin simultaneously assumes its opposite, defying the constraints of space and time as we understand them. The twin photons in a famed experiment become entangled. If one encounters a twist, the other echoes this change, instantly making them an unyielding pair, their destinies inexplicably intertwined. People are drawn to quantum entanglement not just for its scientific implications, but for how it challenges the very fabric of space, time, and reality. It suggests a universe where connections transcend visible links, inviting profound contemplation into the unseen relationships that weave creators within the cosmos. However, navigate this wonder with discernment. While enticing, the complexities of quantum entanglement require a robust grasp of quantum mechanics to avoid oversimplification into misinterpretation or mysticism. To recognize quantum entanglement, engage with explorations into the quantum world, where particles dance their eerie symphony of synchronized states. Such discussions light paths to understanding the deep interconnectedness foundational to quantum theory. When exploring, balance fascination with critical understanding. Embrace both the excitement of new possibilities and the rigor of diligent study, seeking truths from theoretical exploration and vast philosophical potential. As the enigma of quantum entanglement enfolds you, take solace in a world richer and more intricate than first appears. These invisible threads remind you that connections may extend beyond what is observable, inviting discovery and wonder within the ceaseless dance of particles and possibilities. An invitation to a universe that whispers benevolent secrets beyond. Number 13. The anthropic principle, the universe fine-tuned for life. Imagine gazing at the night sky, feeling the vast universe enveloping you in a cosmic embrace. Within this immensity lies a profound question. Could all of this be, in some sense, tailor-made for life? Welcome to the intriguing concept of the anthropic principle. In simple terms, the anthropic principle suggests that the universe's fundamental parameters are finely tuned to allow the existence of life as we know it. It's akin to finding yourself standing in a grand, elaborately designed theater where each seat, sound, and light aligns perfectly for the performance of life. Consider the delicate balance of forces at play, the precise strength of gravity, the exact mass of the proton, the nuanced nature of nuclear forces. These constants seem tailored, creating a universe where stars shine, planets form, and life emerges. Envision the ingredients of our world had the cosmic recipe varied even slightly. The universe might be a sterile expanse, void of the intricate complexity we experience. It sparks a wonder, suggesting that the universe is not just capable of supporting life, but perhaps finely tuned to do so. People are drawn to the anthropic principle as it marries scientific inquiry with philosophical reflection. It invites consideration of our place in the cosmos, suggesting purpose or design in the backdrop of cosmic Chansian interplay between luck and necessity. Yet, when navigating these vistas, exercise care. The anthropic principle can blur lines between scientific reasoning and philosophical interpretation. Without cautious analysis, it might slip into speculative realms, offering more questions than answers. To recognize and engage with this principle, explore dialogues merging cosmology with existential reflection debates, where universal constants harmonize between necessity and serendipity, echoing questions of existence beyond observable boundaries. When engaging, balance admiration with inquiry. Allow the questions raised by the anthropic principle to deepen your exploration of reality, while grounding understanding in both scientific detail and philosophical consideration. As the mystery of the anthropic principle unfolds before you, find serenity in contemplating the universe's poetic precision. Whether an artifact of cosmic luck or encoded purpose, it urges you to ponder deeply upon our existence, perhaps glimpsing in the arrangement of stars, a tapestry intricately etched by the passage of time, partnership between the universe and consciousness, inviting reflection upon the nature of reality. Number 14. Black holes, cosmic monsters defying understanding. Imagine peering into the vastness of space, where the night sky is punctuated by innumerable stars. Yet, lurking within this cosmic tapestry are entities so powerful and enigmatic that they devour light itself. Welcome to the mysterious realm of black holes. In simple terms, a black hole is a region of space where gravity is so intense that nothing, not even light, can escape its grip. It's akin to an invisible beast, cloaked in darkness, its presence perceived only by the influence it exerts on its surroundings. Picture a cosmic whirlpool, where the deeper you journey, the harder it becomes to escape its pull. This is the event horizon point of no return. Once crossed, the fates of all that enter are sealed, drawn inexorably toward the singularity, a core of infinite density and unimaginable gravity. Black holes might form from the remnants of massive stars, collapsing under their own weight at the terminus of their life cycles. Yet, they are not mere celestial tombs. In the swirling accretion disks of matter spiraling toward them, they create some of the universe's most energetic phenomena. People are captivated by black holes as they challenge intuitive understanding of physics. They are gateways to extremes, where the familiar laws of nature unravel and concepts like time and space become beautifully entangled in a cosmic dance. However, be mindful when traversing these mysteries. The allure of black holes can tempt embellishment, drawing one toward fantastical interpretations. Grounding discussions in empirical study and theoretical exploration is crucial for understanding these cosmic enigmas. To recognize and explore black holes, engage with dialogues weaving together gravity's might with the subtleties of relativity and exploration of the boundary where known science meets the profound unknown. When considering black holes, cultivate a blend of wonder and scientific rigor. Embrace the mystery while seeking understanding through the lens of physics and mathematics, where theory and observation align to glimpse these cosmic sentinels. As the enigma of black holes unfolds, find comfort in the world. They reveal a universe of infinite possibilities and boundless secrets, each black hole a testament to the cosmos's unfathomable grandeur. Relish the opportunity to dream and inquire, forging pathways through the shadowed corridors of discovery, where the night holds more than myth, but an invitation to explore the depths of reality. Number 15. Multiverse theory, infinite universes, infinite possibilities. Imagine a universe so vast and varied, its boundaries seem to stretch beyond the grasp of imagination. But what if our universe is but one of countless others, each with its own tapestry of possibilities? Welcome to the captivating realm of multiverse theory. In simple terms, the multiverse theory suggests that our universe, what we see as infinite and all-encompassing, might be just one of an immense number of parallel universes. It's like finding a single book and realizing it belongs to an entire library, each volume narrating a unique tale in the grand saga of existence. Picture a reality where every choice spawns a new path, each divergence creating a new universe with its own distinct storyline. In one universe, you take the road less traveled, while in another, you choose the familiar path. Each decision branches out into a cosmic web of infinite outcomes and experiences. The concept of the multiverse emerges from various scientific theories. Quantum mechanics hints at parallel realities, while cosmology's inflationary models suggest endless universes bubbling forth from an ever-expanding multiversal horizon. Each idea whispers to us that our reality might be one shade in a vast spectrum of existence. People are enchanted by the multiverse theory as it expands the possibilities of what might be. It prompts us to engage with the creative notion that all things possible might indeed exist somewhere, reflecting a complexity and richness beyond our wildest dreams. Yet, proceed with thoughtful consideration. The allure of infinite universes risks producing wild speculation, potentially slipping into realms of conjecture without substantive evidence. Balancing imaginative thought with rigorous analysis is crucial. To recognize and explore multiverse theory, engage with discussions blending quantum mechanics with cosmology, conversations where science and philosophy intersect beautifully across unfathomable scales. When engaging, harmonize curiosity with scientific diligence. Embrace the notion of endless possibility while remaining anchored in methodical exploration, seeking to understand the implications such a framework poses for our understanding of reality. As the enigma of the multiverse unfolds before you, take solace in the wondrous possibility that each universe holds a kaleidoscope of narratives that speaks to the infinite creativity of existence. Marvel at the cosmos's boundless horizons and surrender to the joy of questioning where the boundaries of our universe might lead. Suggests a reality that is richly layered, endlessly immersive, and eternally captivating. Number 16. Advanced civilization hypothesis, lost worlds, or imagination. Imagine wandering through ancient ruins, where each stone whispers tales of forgotten eras and lost wisdom. Yet, within this silence, a question forms. Could there have been advanced civilizations far older and more sophisticated than we have yet to uncover? Enter the fascinating domain of the advanced civilization hypothesis. In simple terms, the advanced civilization hypothesis proposes that highly developed societies may have existed on Earth long before recorded history, leaving behind few traces discernible to modern archaeology. It's akin to discovering a shadow of a once great city, hidden beneath layers of earth and time. Consider the questions. Could some ancient monuments be the remnants of these civilizations? Do stories of mythic cities like Atlantis hold grains of truth, pointing to advanced cultures now shrouded in mystery? The hypothesis invites us to explore the tantalizing possibility that history is deeper and more complex than commonly thought. Cultural echoes in myths and legends from around the world speak of advanced knowledge and technology-lost secrets, washed away by floods or forgotten in the sands of time. These narratives suggest a time when humans might have achieved remarkable feats, now all but vanished. People are captivated by the advanced civilization hypothesis as it challenges traditional narratives of human progress. It sparks our imagination and compels us to rethink humanity's timeline, inviting a deeper exploration of our past. and its impact on the present. Yet, when venturing into these musings, exercise skepticism and diligence. The line between historical inquiry and speculative myth can blur, leading to conjecture without substantiation. Grounding these ideas in evidence-based research is essential. To recognize and engage with this hypothesis, delve into interdisciplinary discussions where archaeology, anthropology, and history converge to explore ancient cultures. Seek evidence and analyze the historical and geological contexts that frame our understanding of human development. When engaging, balance wonder with critical analysis. Embrace the potential revelations that ancient cultures hold while relying on scientific rigor to guide your understanding of what might have once been. As the enigma of the advanced civilization hypothesis unfolds, find solace in the beauty of exploring our collective past tapestry, woven with mystery and knowledge, inviting you to journey through time's shadowy corridors. Reflect on the possibility that echoes of lost worlds might yet teach us about resilience, ingenuity, and the boundless curiosity that defines humanity, preserving a legacy whispered through ages, calling us to listen. Number 17. The Olbers's Paradox. Why is the night sky dark? Imagine yourself enveloped in the tranquility of night, gazing up at a sky peppered with stars. Each point of light holds stories of distant worlds and ancient galaxies. Yet a curious question arises. If the universe is infinite and filled with stars, why doesn't the night sky blaze with light? Welcome to the intriguing puzzle of the Olbers's Paradox. In simple terms, Olber's paradox refers to the apparent contradiction that, in an infinite and eternal universe, the night sky should be bright and uniformly full of stars, rather than predominantly dark. It's like walking into a dense forest wouldn't, every direction, eventually lead your gaze into the heart of a tree. The paradox takes its name from Heinrich Wilhelm Olbers, a German astronomer who articulated this question in the early 19th century. If the universe were static, infinite, and filled uniformly with stars, then every line of sight should end at a star, making the sky as bright as the sun at all times. Consider the universe instead as dynamic and ever-expanding. The light from distant stars takes time to reach us, and some stars are so far away that their light has not reached Earth yet. Moreover, the expansion of the universe stretches the wavelengths of light, reducing the energy we perceive and dimming the light from faraway galaxies into nearly invisible whispers. People are drawn to Olber's paradox as it challenges our perception of the cosmos. It invites us to ponder the relationship between time, light, and the vast, expanding universe, casting everyday observations into profound questions of cosmic architecture. However, in navigating this mystery, maintain clarity over conjecture. The beauty of this paradox lies in its resolution through cosmological principles, rather than speculative imaginings divorced from research and observation. To explore Olbers's paradox, engage with cosmological discussions that delve into the nature of the universe's expansion, the Big Bang, and the evolution of space-time. Such conversations reveal the orchestration of celestial mechanics that shapes what we perceive as darkness. When engaging, blend curiosity with informed inquiry. Allow the wonder of a dark night sky to inspire deeper understanding, using the paradox as a doorway to explore the universe's grand design and nuances. As the enigma of Olber's paradox unfolds, to find comfort in the profound clarity it brings to our celestial view. The dark mantle of night is not just an absence of light, but a testament to a universe in constant motion, ever expanding, ever evolving. It invites reflection upon the nature of existence and our place amidst the stars, a reminder of the beauty hidden in darkness and the eternal light waiting beyond. Number 18. Emergence, complexity from simplicity. Imagine observing a flock of birds as they sweep across the evening sky, moving in perfect harmony. No leader commands them, yet a pattern as intricate as it is beautiful unfolds a dance of coordinated chaos. Welcome to the fascinating phenomenon of emergence, where complexity arises from simplicity. In simple terms, emergence describes how complex systems and patterns emerge from relatively simple interactions among components. It's like watching an intricate tapestry being woven from basic threads, creating a masterpiece that is far greater than the sum of its parts. Think of a snowflake, for example. Its exquisite, unique pattern emerges from the basic principles of chemistry and temperature as water molecules join in a crystalline dance. Or consider a bustling city. Each individual move, seemingly trivial, contributes to the dynamic life and rhythm of urban existence. Delving deeper, you encounter emergence in the natural world, where the interplay of molecules leads to the miraculous spark of life, or within ecosystems where diverse organisms exist in balanced interdependence, creating thriving habitats from simple biological interactions. People are captivated by emergence as it challenges traditional notions of order and control. It suggests a universe where the underlying simplicity gives rise to remarkable complexity and interplay of chaos and order that invites us to find beauty and meaning in the interconnectedness of all things. Yet, navigating emergence requires care in distinguishing genuine patterns from artificial constructions. The allure of apparent complexity can sometimes lead to misunderstanding, assuming causality where none exists without careful examination. To recognize and appreciate emergence, engage with dialogues merging science, philosophy, and art. Explore how simple rules and interactions lead to unexpected properties and behaviors, inviting curiosity about the nature of systems, be they biological, social, or computational. When engaging, foster a balance of wonder and critical analysis. Embrace the insights that emergence offers into natural systems while remaining grounded in evidence-based exploration and scientific inquiry. As the wonder of emergence unfolds before you, embrace the harmony within complexity, a symphony where simplicity delights in creating sophistication. This concept reminds us that even the most intricate patterns of existence start from modest beginnings, inviting us to appreciate the hidden depths within simplicity and the ornate designs woven through the fabric of reality. Number 19. The holographic principle is the universe a 3D projection. Imagine walking through an art gallery where each painting comes alive with depth and detail. Yet as you step closer, you realize these vibrant scenes are mere two-dimensional illusions, cleverly rendered into apparent three-dimensional spaces. Enter the intriguing possibility of the holographic principle, which suggests that our universe might be a grand projection. In simple terms, the holographic principle posits that all the information contained in our three-dimensional world might actually be encoded on a two-dimensional surface, a cosmic hologram of sorts. It's like the surface of a black hole containing all the data necessary to reconstruct everything within it, reflecting a broader insight into the universe itself. Consider a hologram on a credit card. It appears three-dimensional, though it is printed on a flat surface. Similarly, the holographic principle suggests that our perception of depth and space could be a projection of information from a boundary of lower dimensions. The principle has roots in theoretical physics, particularly in the study of black holes. Physicists realized that the information regarding particles swallowed by a black hole might reside on its surface, rather than lost within its depths of revelation, extending to the cosmos at large. People are drawn to the holographic principle as it challenges our fundamental understanding of reality. It invites us to reconsider what we perceive as solid, opening doors to speculative realms where the universe's true nature might be vastly different from everyday experience. However, in contemplations of this mystery, balance imagination with critical scrutiny, distilling theoretical explorations into comprehensible truths is essential to avoid drifting into unfounded speculation. To recognize and explore the holographic principle, delve into dialogues weaving physics with profound philosophical implications discussions, where cosmology and quantum mechanics converge to unravel the universe's complex tapestry. When engaging, nurture a blend of wonder and scientific exploration. Allow these concepts to inspire a deeper inquiry into the nature of reality, while leaning on rigorous scientific frameworks to ground understanding. As the enigma of the holographic principle unfurls, find solace in reflecting upon the staggering possibilities. It proposes that each corner of existence might encode the story of the universe. Consider the universe as a cosmic theater, where the stage might reside not in the observed expanse, but in unseen dimensions that cradle the ultimate truth, inviting endless curiosity and contemplation in the quest to decode the universe's mysteries. Number 20. The Boltzmann brain. Are we just cosmic flukes? Imagine for a moment, floating in the vast expanse of space, a solitary consciousness, fleeting and untethered. This whim of the cosmos challenges our understanding of reality. Could our very existence be nothing more than an improbable fluctuation, a quirk in the universe's endless play? Welcome to the mind-bending concept of the Boltzmann brain. In simplest terms, the Boltzmann brain hypothesis proposes that it's plausible, in an infinite universe, for self-aware entities to spontaneously arise from random fluctuations, fully formed with memories and a sense of self. It's like conjuring a character from a novel, complete with a backstory, suddenly appearing in stark isolation. This idea stems from the musings of physicist Ludwig Boltzmann, who pondered entropy and the likelihood of order occasionally forming in an otherwise chaotic cosmos. The hypothesis posits that, given infinite time, a brief, self-aware consciousness might emerge randomly and improbably within the cosmic stew. Consider the implications. In such a universe, isolated intelligences flicker into existence, questioning their own reality before dissolving back into the void. The unsettling notion suggests that what we perceive as a consistent and structured universe might itself be the greater improbability compared to these ephemeral brains. People explore the Boltzmann brain hypothesis as it provokes profound philosophical inquiry into the nature of consciousness, existence, and the logical structure of the universe. It challenges our notions of identity and reality, inviting a deep discourse on what it means to be truly aware. Yet, tread cautiously in this domain of speculative thought. The allure of radical ideas requires grounding in rational discourse to balance meaningful contemplation with the potential for paradoxical conclusions. To recognize and consider the Boltzmann brain, delve into discussions bridging the realms of cosmology, philosophy, and consciousness dialogues where boundaries blur and the improbable becomes a canvas for exploration. When engaging, blend curiosity with a keen sense of logic. Embrace the philosophical implications of the Boltzmann brain while anchoring understanding in physics and reasoned critique. As the enigma of the Boltzmann brain unfolds, find solace in the exploration of profound possibilities. Whether we are cosmic anomalies or intricately woven into a purposeful universe, the question casts light on the depth and richness of existence itself. It invites us to cherish the dance of consciousness and the mystery of being, stretching across the lonely vastness into a shared wonder of life and awareness. Number 21. The problem of free will. Are we really in control? Imagine standing at a crossroads, a decision weighing on your mind. You ponder the choices before you, feeling the essence of freedom in selecting your path. But when you peel back the layers of thought and action, a profound question emerges. Are we truly in control of our decisions? Welcome to the intricate exploration of the problem of free will. In simple terms, the problem of free will delves into whether our choices are genuinely autonomous or predetermined by a combination of biology, environment, and fate. It's akin to choosing a book from a shelf, only to wonder if the selection was yours or subtly directed by unseen hands. Think about the infinitesimal moments leading to an actiona decision, spurred by past experiences, genetic predispositions, or situational context. Are we genuine authors of our fate, or do these unseen forces compose the narrative of our lives? Philosophers and scientists alike ponder the complexity of free will. Some argue that if the universe is governed by physical laws, our sense of choice may be an illusion, a deterministic chain reaction written from the cosmos's birth. Others propose that even within this determinism, freedom arises through unpredictability and conscious deliberation. People are drawn to the problem of free will as it directly questions the essence of human agency, morality, and responsibility. It invites a contemplation of what it means to live thoughtfully and authentically in a universe intertwined with constraints. However, when navigating this enigma, tread with care. The allure of philosophical debate can lead to a maze of paradox, where clarity and uncertainty entangle. Thus, grounding in reasoned discourse is essential. To recognize and engage with the problem of free will, explore dialogues converging neuroscience, philosophy, and introspection discussions, where the nature of choice dances between freedom and determination. When engaging, maintain a balance of curiosity and critical inquiry. Embrace the question's free will ignites while holding on to empirical insights and philosophical exploration. As the mystery of free will unfolds before you, find solace in the depth of exploration it offers. Whether freedom is an innate quality or an artful illusion, the journey of understanding shapes a deeper awareness of self and existence. It invites you to treasure the dance of autonomy within life's wondrous story, a reminder that each choice, real or perceived, weaves the unique tapestry of life's narrative. Number 22. The P versus NP problem, the limits of computation. Imagine a labyrinth of endless complexity, where the path from start to finish is obscured by intricacies and dilemmas. Now envision possessing a blueprint that reveals the way forward. Yet crafting this map remains elusive. Dive into the world of large-scale computation with the P versus NP problem, a riddle at the heart of computational theory. In simple terms, the P versus NP problem asks whether every problem whose solution can be quickly verified can also be solved quickly. Essentially, it's about determining if problems that are easy to check are equally easy to solve. It's like figuring out if piecing together a puzzle is as manageable as confirming the pieces form a coherent picture when assembled. In computational terms, P represents problems that can be solved quickly by an algorithm, while NP refers to problems whose solutions, once found, can be quickly verified. The tantalizing question is whether these two classes are indeed separate or perhaps the same, revealing profound implications for fields ranging from computer science and cryptography to logistics and beyond. Consider the challenge of determining the most efficient route for a traveling salesperson, or ensuring the integrity of encryption systems safeguarding sensitive data. Solving P versus NP could unleash new computational capabilities, transforming everything from scientific research to the daily conveniences powered by technology. People are captivated by the P versus NP problem, as it symbolizes the edge of mathematical and computational understanding. It embodies the pursuit of knowledge, a quest to uncover the computational secrets underlying the vast landscapes of possibilities. Yet, when exploring this enigmatic frontier, proceed with patience and precision. Simplifying its nuances into relatable terms is challenging, demanding a careful dance between theoretical rigor and accessible understanding. To recognize and engage with the P versus NP problem, delve into discussions bridging algorithms with theoretical exploration intersecting dialogues, where computation meets the uncharted territories of mathematical possibility. When engaging, balance curiosity with critical perspective. Allow this grand challenge to inspire deeper contemplation on our relationship with technology, anchoring inquiries in the ever-evolving landscape of computational science. As the enigma of the P versus NP problem unfurls, find solace in the richness of unexplored potential. Whether the answer lies within reach or distant in the shadows of future discovery, this journey invites the imagination to ponder the limits of computation and the boundless horizons beyond, a testament to human ingenuity and the relentless curiosity that drives us to unlock the universe's complexities. Number 23. The Riemann hypothesis, enigma of prime numbers. Imagine standing at the frontier of mathematical exploration, where numbers whisper secrets spanning the infinite. In this realm, prime numbers stand as silent sentinels, unfathomably ordered yet mysteriously chaotic. Welcome to the profound mystery of the Riemann hypothesis. In simple terms, the Riemann hypothesis proposes a deep connection between the distribution of prime numbers and the zeros of the Riemann zeta functioner, complex function that encodes insights into prime behavior. It's akin to discovering a hidden pattern in the cosmos, where scattered stars reveal a celestial rhythm housed within their vastness. At the heart of this hypothesis is a question as old as mathematics itself. How are prime numbers, the building blocks of arithmetic, distributed among the integers? The Riemann hypothesis suggests that all non-trivial zeros of the zeta function lie on a particular line in the complex plane, a mystical alignment that could unlock prime numbers' elusive structure. Consider how prime numbers serve as keys to cryptographic security, or how their unpredictable distribution poses challenges and opportunities in mathematical research. Proving the Riemann hypothesis may usher in significant advancements, transforming fields linked to these fundamental numeric puzzles. People are captivated by the Riemann hypothesis as it blurs the lines between order and chaos, inviting mathematicians to uncover harmony within apparent randomness. It stands as one of the Clay Mathematics Institute's 7 Millennium Prize problems, symbolizing a pursuit of purity and precision in understanding. Yet, tread carefully through these mathematical marvels. While enticing, the complexity of the hypothesis demands thorough comprehension and thoughtful discourse to appreciate its beauty fully. To engage with the Riemann hypothesis, explore discussions where complex analysis converges with number theory, creating a dialogue that traverses abstract ideas and tangible implications alike. As the mystery of the Riemann hypothesis unfolds, balance curiosity with diligence. Embrace the challenge as an opportunity to reflect on universal truths hidden within numbers, using rigorous mathematical reasoning as your guide. As you linger on the enigma of the Riemann hypothesis, find solace in the pursuit of knowledge it inspires. Whether eventual proof or perpetual quest, it enriches our understanding of numerical order, weaving a legacy of curiosity and intellectual endeavor. This journey beckons you to contemplate the subtleties and wonders that mathematics harbors, connecting threads that span the course of centuries. Number 24. The Mandela Effect, Memory, Reality, and False Recollection. Imagine a shared memory, vivid and distinct, yet in a twist of reality, never having existed. It feels like a collective recollection from a parallel universe where subtle details diverge. Welcome to the intriguing phenomenon of the Mandela Effect. In simple terms, the Mandela Effect occurs when a large group of people remembers something differently than it occurred. It's like witnessing a play where actors suddenly change their lines, leaving the audience puzzled by the discrepancy between expectation and truth. The phenomenon's name stems from the widespread, yet incorrect belief that Nelson Mandela died in prison in the 1980s, a memory held by many, despite his actual passing in 2013. This paradox highlights how memories, at times, weave narratives distinct from verified history. Consider common examples, like the misremembered spellings of popular brands, or altered lines from iconic films. Why do so many recall the line, "Luke, I am your father," instead of the actual, "No, I am your father"? Such instances reveal the delicate nature of memory and its susceptibility to distortion. People are fascinated by the Mandela Effect as it delves into the mysteries of cognitive psychology, prompting questions about the mechanics of memory, perception, and reality. It compels us to explore how cultural exchanges and shared experiences shape collective recollections, offering insights into the mind's interpretation of events. Yet, as you navigate this phenomenon, tread carefully around the boundary between curiosity and illusion. The allure of seemingly parallel realities can lead to speculative narratives, emphasizing thoroughness in examining the psychological underpinnings of memory. To recognize and explore the Mandela Effect, engage with discussions that bridge psychology, culture, and neuroscience dialogues that illuminate the human mind's intricate processes amid the tapestry of stories it spins. As you ponder the Mandela effect, balance fascination with inquiry. Relish the questions it inspires, yet remain anchored in empirical research and cognitive insight, revealing how even concrete memories may shift like shadows on the wall. As the mystery of the Mandela effect unfolds, find solace in understanding that memory, with its fluidity, invites perpetual exploration. Whether product of a collective imagination or windows into a more profound reality, this phenomenon invites you to appreciate the elastic nature of human recollection and ever-evolving canvas, reflecting our shared narratives. Number 25. The placebo effect, mind over matter in medicine. Imagine the healing power of belief, a simple pill, devoid of active ingredients, yet capable of sparking genuine change in one's health. Welcome to the fascinating world of the placebo effect, where expectation and perception intermingle with physiological response. In simple terms, the placebo effect occurs when patients experience real improvements in their conditions after receiving treatments with no therapeutic value. It's like brewing a potion with the power of suggestion, where healing is conjured from belief rather than conventional science. This phenomenon finds its roots deep within medical science, where placebo-softened sugar pills or saline solutions play pivotal roles in clinical trials. Doctors employ them to discern the genuine efficacy of new treatments by comparing outcomes to those triggered by sheer belief. Consider a patient given a placebo to relieve pain. Remarkably, through the mind's intricate dynamics, they may report diminished suffering as the brain releases endorphins, natural chemicals that alleviate discomfort. Herein lies the mind's mysterious ability to influence health through expectation. People are drawn to the placebo effect as it bridges the realms of psychology, medicine, and philosophy. It challenges our understanding of healing, asking, how much of recovery stems from the treatments themselves, and how much from the patient's belief in those treatments? Yet, as you explore this enigma, approach with thoughtful discernment. While intriguing, the placebo effect highlights the mind's power, but also underscores ethical considerations within medicine, where patient trust and treatment integrity must be upheld. To engage with the placebo effect, explore dialogues converging medical research and cognitive science, unraveling how belief collaborates with biology to produce palpable effects. As you ponder the placebo effect, balance wonder with scientific inquiry. Embrace the phenomenon's insights as invitations to examine the intersections of mind and body, exploring how deeply our perceptions shape our realities. As the mystery of the placebo effect unfolds, to find solace in the resilience and complexity of human nature it reveals. Whether a testament to the power of hope or an artifact of experimental design, this phenomenon invites reflection on the profound connections between belief, perception, and healing, encouraging a deeper understanding of the inherent capacity for self-healing and resilience within us all. Number 26. Fermat's last theorem, a 300-year mathematical riddle. Imagine an enigma penned in the margins of a book, a simple assertion sparking the imaginations of mathematicians for generations to come. This seemingly modest note would evolve into one of the most enduring puzzles in the realm of mathematics. Welcome to the tale of Fermat's last theorem. In simple terms, Fermat's last theorem posits that there are no whole number solutions to the equation x n plus y n equals z n for y, n, greater than 2. It's as though an architect declared an architectural wonder possible with the simplest tools, yet left no blueprint to its construction. The theorem takes its name from Pierre de Fermat, a 17th century mathematician who inscribed this bold claim in the margins of his copy of an ancient Greek text. His note teased of a truly marvelous proof that the margin was too narrow to contain. For over 3 centuries, this cryptic challenge eluded solution, prompting intrigue and extensive inquiry within the mathematical community. The theorem's apparent simplicity belied the immense complexity required to grasp its truth quest, consuming the energies of many seeking to unlock its secrets. Consider the story of Andrew Wiles, a mathematician who, more than 350 years later, would illuminate Fermat's mysterious claim. Through dedication and ingenuity, Wiles devised a proof, intertwining fields of mathematics that, on the surface, seemed unrelated. His work not only settled Fermat's last theorem, but inspired a new generation of inquiry into the beautiful intricacies of mathematics. People are drawn to Fermat's last theorem as it embodies the enduring allure of intellectual challenge and persistence. It symbolizes the balance of simplicity and complexity, a reminder of mathematics as an ever-evolving exploration. Yet, as you ponder this tale, appreciate the harmony between wonder and rigor that it demands. The theorem underscores the pursuit of knowledge through painstaking labor and collaborative insight across eras. To explore Fermat's last theorem, dive into discussions bridging number theory and mathematical history explorations that reveal the theorem's profound impact on mathematics and its community. As the mystery of Fermat's last theorem unfolds, to find solace in its resolution and the journey it represents, whether viewed as a landmark achievement or a catalyst for further discovery, it stands as a testament to human curiosity and resilience nurturing the universal quest for understanding and the bonds that unite seekers of truth through time. Number 27. The uncertainty principle, limits of precision in measurement. Imagine peering through a microscope, striving to grasp the mysteries of the tiniest particles in the universe. Yet, as you focus in, the vision shifts, evading absolute clarity, a dance of precision and mystery. Welcome to the world of the uncertainty principle. In simple terms, the uncertainty principle, formulated by Werner Heisenberg, posits that certain pairs of physical properties, like position and momentum, cannot be simultaneously known to arbitrary precision. It's akin to trying to perfectly capture a moving object in a photograph, with either the subject or surroundings blurring as you attempt to sharpen your view. Consider the dual nature of light and particles. To pinpoint an electron's position is to shroud its momentum in mystery, and vice versa. As the focus sharpens on one aspect, the other drifts into obscurity, inviting us to rethink how we perceive the foundations of reality. This principle isn't a mere limit of technology or measurement sophistication. It delves into the very fabric of quantum behavior. It suggests a universe where certainties are woven with probabilities, forming a delicate dance of knowledge and potential. People are drawn to the uncertainty principle as it challenges the deterministic worldview that once seemed secure. Its implications ripple through science and philosophy alike, questioning the nature of reality, choice, and knowledge. Yet, as you delve into this fascinating concept, approach with thoughtful balance. While it unravels traditional notions, the principle also lays the groundwork for modern quantum mechanics. requiring diligence in understanding the depth of its implications. To explore the uncertainty principle, seek discussions where quantum theory meets philosophical inquiry engagements that unravel the layers of complexity inherent in perception, observation, and the physical world. As you ponder the mystery of the uncertainty principle, blend curiosity with foundational knowledge. Allow it to inspire a deeper contemplation of existence, revealing the nuances of understanding that brace against absolutes. As the mystery of the uncertainty principle unfolds, it finds solace in the beauty of possibilities it reveals. Whether as a philosophical concept or a scientific revelation, it invites you to appreciate the unity of precision and uncertainty, the elegant dance that composes the symphony of the universe, whispering its secrets of imperfection and insight through a quantum lens. Number 28. Gödel's incompleteness theorems, the limits of reason. Imagine standing in the vast halls of logic, where every stone is laid with precision, each pillar a testament to reason. Yet, within this bastion of thought, a whisper emerges, hinting at shadows beyond reach. Enter the realm of Gödel's incompleteness theorems, where the limits of reason are elegantly revealed. In simple terms, Gödel's incompleteness theorems demonstrate that in any coherent system of arithmetic, there are truths that cannot be proven within the system itself. It's like composing a symphony where some notes, exquisite and resonant, remain silent, echoing their presence through absence. Kurt Gödel, a logician of profound insight, unveiled these theorems in the early 20th century. His work reveals that mathematical systems, no matter how well defined, harbor inherent limitation statements, true yet unprovable, constants that lie just beyond the reach of established logic. Consider this: within any richly consistent system, questions arise whose answers elude the very framework in which they dwell. This discovery sends ripples through the landscapes of mathematics and philosophy, challenging the certainty of systems long held sacred. People are drawn to Gödel's incompleteness theorems as they explore the boundaries of logic itself, prompting reconsideration of what is knowable and what remains shrouded in mystery. These theorems highlight a universe where knowledge is endless, yet sometimes tantalizingly incomplete. Yet, as you ponder these profound revelations, embrace them with careful reflection. The allure of Gödel's work can beckon toward philosophical depths where certainty and uncertainty intertwine ambiguities that merit clear-eyed contemplation. To understand Gödel's incompleteness theorems, explore discussions that bridge mathematics with philosophical reasoning dialogues that illuminate the delicate dance between provability and truth. As the enigma of Gödel's incompleteness theorems unfolds, find comfort in the humility they inspire. Recognize the beauty in imperfection, the grace in acknowledging limits, and the invitation these boundaries offer to go ever deeper into exploration. As you ponder these mathematical mysteries, find solace in the vast landscapes of thought they open, whether questioning the reach of reason or marveling at the intricate web of logic. Allow these theorems to invite you into a meditation on the richness and complexity of the human understanding, encouraging a journey beyond certainty, where inquisitiveness and wisdom intertwine. Number 29. The Hubble tension, mysteries of an expanding universe. Imagine gazing into the night sky, where distant galaxies stretch toward infinity, forever in motion. Yet, within this cosmic dance, a conundrum unfolds, a subtle discord that challenges our understanding of the universe's expansion. Welcome to the enigmatic realm of the Hubble tension. In simple terms, the Hubble tension refers to a significant discrepancy between two precise measurements of the universe's expansion rate. It's like hearing two versions of a familiar melody, each harmonious on its own, yet discordant when played together, revealing a cosmic mystery at the heart of our universe. The roots of this tension lie in the Hubble constant, a value that describes how quickly the universe is expanding. One approach measures this rate through observations of distant cosmic events, such as supernovae or the cosmic microwave background radiation. Another approach gauges the expansion by studying the local universe and the dynamics nearby galaxies. However, these methodologies yield divergent results, each steadfast in its precision, yet at odds with the other. This discrepancy with Hubble tension raises profound questions about the fabric of the cosmos. Could there be unknown physics at play, or might these differences signal gaps in our current cosmological models? People are captivated by the Hubble tension as it highlights the frontiers of modern astrophysics, inviting scientists to delve deeper into understanding universal expansion. It serves as a beacon for curiosity, pushing the boundaries of exploration and knowledge. Yet, as you traverse this cosmic puzzle, approach with a balanced perspective. While the tension sparks profound intrigue, resolving it demands careful analysis, creativity, and potentially new theoretical frameworks. To engage with the Hubble tension, explore dialogues in cosmology where theoretical physics meets astronomical observation. These discussions reveal the challenges and opportunities of interpreting the universe through both cutting-edge technology and timeless curiosity. As you ponder the Hubble tension, allow wonder and rigor to guide your understanding. Let the questions it raises inspire contemplation of the universe's grand tapestry, interwoven with mysteries yet untold. As the enigma of the Hubble tension unfolds, find solace in the endless exploration it invites. Whether pointing toward uncharted physical laws or prompting new cosmic models, this paradox fuels the quest for understanding, a testament to the vastness and complexity of the universe, where each question illuminates the path to deeper discovery, revealing the harmonies and dissonances of a cosmos in perpetual expansion. Number 30. The BeSleepSmart controversy, gravitational waves and inflation. Imagine peering back to a time when the universe was a mere whisper, just fractions of a second after the Big Bang moment, potentially captured by primordial ripples etched into the cosmic fabric. Welcome to the whirlwind story of the BeSleepSmart controversy. In simple terms, the BeSleepSmart experiment was designed to detect cosmic inflation's fingerprints, gravitational waves, believed to be generated in the universe's earliest moments. It's akin to deciphering echoes of an ancient drumbeat that set the rhythm for the cosmos. In 2014, the BeSleepSmart collaboration announced what seemed to be a groundbreaking discovery: the detection of these primordial gravitational waves, ripple signatures, in the cosmic microwave background radiation. This announcement sparked excitement, promising new insights into the universe's infancy and lending significant support to the theory of inflation and exponential expansion post-Big Bang. However, this excitement was soon tempered by scrutiny. Further analysis revealed that the observed signals could largely be attributed to cosmic dust within our galaxy, casting doubt on the initial claim. The realization unfolded as a sobering reminder of the meticulous nature of scientific inquiry and the complexities of distinguishing genuine cosmic signals from terrestrial noise. People are drawn to the BeSleep 2 controversy as it captures both the thrill and humbling challenges of scientific exploration. It underscores the intricate journey from hypothesis to discovery, highlighting the need for rigor and verification. Yet, as you navigate this narrative, appreciate the balance between discovery and due diligence it demands. The story serves as a testament to the scientific method's robustness, where initial breakthroughs must withstand rigorous examination and independent corroboration. To explore the BeSleep 2 controversy, delve into discussions where cosmology and astrophysics intersect, unveiling insights into how the universe communicates its ancient past through subtle cosmic signals. As you reflect on the BeSleep 2 controversy, balance wonder with critical analysis. Embrace the complexity of scientific discovery as both an adventure and a process integral to our evolving understanding of the universe. As the story of the BeSleep 2 controversy unfolds, it finds solace in the resilience and dedication it reveals within the scientific community. Whether a precursor to future revelations or a lesson in the pursuit of truth, this controversy invites reflection on the ever-evolving nature of exploration, a reminder that each step forward in understanding may be accompanied by a cautious step back, a dance where the universe's profound symphony patiently, yet persistently, unfolds its mysteries. Number 31. The Great Attractor, a cosmic mysterious pull. Imagine gazing into the vast expanse of the cosmos, where galaxies drift silently through the universe. Yet, amid this serene drift, an invisible hand guides our galactic path, slowly pulling us toward an unknown destination. Enter the enigmatic realm of the Great Attractor. In simple terms, the Great Attractor is an immense gravitational anomaly situated in the region of space known as the Laniakea supercluster. It's like discovering a hidden whirlpool in a vast ocean, its currents stretching far and wide, influencing the motions of everything within reach. Our Milky Way galaxy, along with our cosmic neighbors, is subtly drawn toward this mysterious region at staggering velocities. Though we cannot see it directly veiled by a dense wall of intergalactic stars and dust, its gravitational influence betrays its presence. The Great Attractor lies within the so-called zone of avoidance, obscured by the Milky Way's plane, making its true nature elusive. Is it a colossal cluster of galaxies, or perhaps something even more extraordinary, hiding behind cosmic veils? People are fascinated by the Great Attractor as it embodies the mystery and grandeur of the universe. It prompts contemplation of the unseen forces and structures that govern the cosmos, challenging our understanding of gravitational dynamics on an epic scale. However, as you explore this enigma, approach with humility and curiosity. While compelling, the Great Attractor reminds us of the universe's vast unknowns and the careful observation needed to decode its secrets. To engage with the mystery of the Great Attractor, delve into discussions bridging observational astronomy and theoretical physics explorations that seek to reveal the veiled intricacies of our cosmic neighborhood. As you ponder the Great Attractor, balance wonder with empirical inquiry. Let the curiosity it inspires guide your exploration of gravitational influences and space's unseen architecture. As the enigma of the Great Attractor unfolds, to find solace in the vast possibilities it proposes. Whether an invitation to future discovery or a riddle waiting to be unraveled, it reflects the universe's dynamic and majestic Naturean endless dance of galaxies within the tapestry of the cosmos. Embrace the journey to uncover not just where we are heading, but the profound forces that shape our path, echoes of the universe whispering stories yet untold. Number 32. The fifth force, beyond the known forces of nature. Imagine a universe woven together by fundamental forces, each an artist shaping the cosmos in its subtle ways. But what if there's another forsayer, hidden maestro completing this celestial symphony? Welcome to the intriguing possibility of the fifth force. In simple terms, the concept of a fifth force suggests the existence of a fundamental interaction beyond the four known forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. It's akin to finding a missing note in a familiar melody, one that could harmonize existing theories and extend our understanding. The notion of a fifth force arises from anomalies and unexplained phenomena observed in various experiments. Scientists have long sought evidence of additional forces to provide explanations for dark matter, cosmic inflation, or to unify existing forces into a single theoretical framework, such as a grand unified theory. Consider experiments that hint at deviations from gravitational predictions or unexpected particle interactions whispers from the universe, urging us to listen more closely to the hidden symphony of forces at play. These possibilities invite excitement and caution alike. People are captivated by the idea of a fifth force, as it challenges the completeness of our existing models and opens new avenues for exploration, potentially uncovering secrets buried in the universe's fabric. Yet, as you navigate this concept, exercise discernment. The allure of the unknown must be balanced with rigorous scientific methods and careful interpretation of data to distinguish genuine breakthroughs from fleeting anomalies. To explore the notion of a fifth force, delve into discussions of modern physics and cosmology engagements, where theoretical and experimental physics converge, attempting to unveil the deeper layers of reality. As you ponder the fifth force, blend curiosity with empirical rigor. Let it inspire wonder about the universe's complexity, while grounding your understanding in both experimental evidence and theoretical inquiry. As the mystery of the fifth force unfolds, to find solace in the uncharted possibilities it suggests. Whether revealing a new facet of cosmic architecture or sparking innovative questions, this idea invites us to ponder the unknowns that might yet reshape our understanding of nature. Embrace the journey toward discovery, where the universe's hidden harmonies lie waiting, eager to share their notes with those daring enough to seek them out. Number 33. The triple point, matter's strange behaviors. Imagine witnessing matter in its most enchanting dance, a moment where solid, liquid, and gas coexist in perfect harmony. This otherworldly balance is found at the triple point, where the simplicity of states converges into elegant complexity. In simple terms, the triple point of a substance is the unique set of condition-specific temperature and pressure rate, which its three phases exist in equilibrium. It's like standing at the crossroads of a celestial ballet, where distinct dancers share the stage in a fleeting yet perfect alignment. Picture water at its triple point, where ice crystals, liquid droplets, and vapor molecules interact seamlessly, balancing delicately on nature's scales. This specific set of circumstances provides insight into the fundamental properties of matter and the conditions under which it transforms. Beyond water, Every substance has its own triple point, offering a window into understanding phase transitions and the behavior of materials under varied conditions. These principles are foundational in fields ranging from thermodynamics to planetary science, where understanding matter's state enhances our grasp of both earthly and cosmic environments. People are captivated by the triple point, as it illustrates the inherent interconnectedness of nature's facade dance of matter that challenges the boundaries between states while revealing the nuanced interplay upheld by nature's laws. Yet, while uncovering the triple point's mysteries, embrace the need for precision it demands. Recognizing the transient balance requires meticulous study, where subtle nuances of temperature and pressure define the boundaries of this unique equilibrium. To explore the triple point, engage in discussions that traverse the realms of physics and chemistry, where the fundamentals converge with practical applications from laboratory settings to the atmospheres of distant planets. As you ponder the triple point, blend wonder with scientific inquiry. Allow the grace of this phenomenon to inspire deeper exploration into the secrets of matter's states, while anchoring understanding in empirical research and experimental verification. As the enigma of the triple point unfolds, find solace in the elegant simplicity it reveals. Whether a gateway to understanding transformations or a glimpse into nature's balance, this unique intersection beckons you to marvel at the harmonious dance of matter where boundaries blur and possibilities emerge, weaving a tapestry of discovery where the known and unknown meet. Number 34. Epigenetics, beyond DNA in genetic expression. Imagine a symphony composed not just of notes on a page, but influenced by the subtle touches of a conductor shaping the music in unexpected and complex ways. Welcome to the fascinating world of epigenetics, where genetic expression dances beyond the simple sequence of DNA. In simple terms, epigenetics refers to the study of changes in gene expression that do not involve alterations to the underlying DNA sequence. It's like an artist's brush adding strokes to a canvas, modifying the image without changing the foundational structure beneath. Consider the potential encapsulated within your genetic code-rich library of potential awaiting activation. Epigenetic mechanisms act as editors, turning certain genes on or off in response to environmental cues, lifestyles, and even stress. Their impact can ripple across generations, illustrating how external factors wield the power to shape our biological destiny. Picture identical twins, born with the same genetic blueprint, yet leading different paths. Their environments influence their epigenetic markers, leading to unique characteristics and health profiles. Despite their shared DNA, these effects illustrate the profound ability of epigenetic mechanisms to mold individuality. People are drawn to epigenetics because it challenges the once static view of genetics as predestined, introducing a dynamic interplay between our genes and environment. It highlights the profound connections between biology, environment, and the continuous interactions that craft our individuality. However, as you explore these insights, tread thoughtfully. While epigenetic research unlocks new dimensions of understanding, the complexity of interactions cautions against oversimplification or deterministic interpretations. To delve into epigenetics, engage with discussions at the crossroads of genetics, biology, and environmental science explorations, examining how these influences sculpt individual and collective health landscapes. As you ponder the dance of epigenetics, balance wonder with informed inquiry. Allow the insights it offers to deepen your consideration of what forms individual identity, while grounding understanding in both established research and emerging discoveries. As the enigma of epigenetics unfolds, find solace in the possibilities it reveals. Whether redefining our relationships with health and heredity, or considering the broader implications for human evolution, this discipline invites you to appreciate the intricate interplay of life's forces. Embrace the journey into epigenetics, where the boundaries of nature and nurture blur, creating a delicate tapestry woven by DNA and experience, a testament to the adaptability and complexity of life. Number 35. The information paradox. Black holes and lost data. Imagine throwing a book into a fire. You know the ashes, smoke, and heat still contain traces of what the book was. Its energy is conserved. But throw that same book into a black hole, and what happens? Does the information it carried simply vanish? That's the heart of the information paradox, a deep conflict between general relativity and quantum mechanics. According to Einstein's theory, anything that crosses a black hole's event horizon disappears from our universe, gone. But quantum theory insists that information even down to the quantum state of particles can never be truly lost. The two ideas clash at a fundamental level. One says, erased. The other says, never. Stephen Hawking once proposed that black holes destroy information. Later, even he doubted that. Some physicists now believe that information is somehow encoded in the Hawking radiation black holes emit. Others suggest it might be preserved on the event horizon, like a hologram. No one knows the final answer, but the paradox has pushed science forward, revealing the cracks between gravity and quantum rules, between what we observe and what might be hidden behind the veil of space-time. A black hole doesn't just warp space, it warps certainty. And the more we learn, the more mysterious it becomes. Number 36. The Goldilocks zone, where life might thrive. Not too hot, not too cold, just right. That's the Goldilocks zone, the orbital sweet spot where a planet might be able to support life. In our solar system, Earth sits comfortably in this zone where water can exist as a liquid, and temperatures aren't too extreme. Venus is too hot, Mars is too cold. But Earth is balanced, at least for now. Astronomers use this concept to search for life in other star systems. When they find exoplanets, the first question is often, is it in the habitable zone? But being just right is more than distance. The planet also needs the right atmosphere, the right chemical mix, the right magnetic protection. The zone is a start, not a guarantee. Still, the idea is powerful. It suggests that life as we know it might not be rare. If Goldilocks zones exist around billions of stars, some might host conditions similar to Earth. And in the vast silence of space, that possibility whispers something hopeful, that maybe, somewhere, under a distant sky, life is breathing quietly. Number 37. String theory, the quest for a unified theory. Imagine everything in the universe matter, energy. Gravity is made from tiny vibrating strings, not particles, but loops. That's the central idea of string theory, a bold attempt to unify all the laws of physics into one elegant framework. String theory says that what we think of as particles are just different vibrational modes of one-dimensional strings. Electrons, quarks, even gravity itself, all arise from how these tiny loops vibrate. It's like music at the smallest scale. Change the vibration, and you change the particle. The theory also requires extra dimensions, not just the 3 we see, or the 4th we experience through time, but 10, 11, or more. These extra dimensions might be curled up so tightly we never notice them. They're hidden, but mathematically necessary. Critics argue that string theory isn't testable. No one has observed a string. No experiment has confirmed its claims. But still, it holds something magnetic, a vision of unity, a belief that beneath all the forces, there's just one fundamental thread, weaving the universe together. It may be true, it may not, but even in speculation, we edge closer to the truth. Number 38. Quantum tunneling, particles that walk through walls. In our everyday world, walls are barriers, solid, impenetrable. But in the quantum world, particles don't follow those rules. They can do something strange. They can tunnel through barriers, even when they seemingly don't have enough energy to cross them. That's quantum tunneling, one of the strangest and most essential features of quantum mechanics. Imagine a ball rolling toward a hill. If it doesn't have enough speed, it rolls back. But in the quantum world, that same ball might disappear and reappear on the other side, not by jumping over, but by slipping through, as if the wall briefly stopped existing. This isn't just theory, it happens. Nuclear fusion in the sun relies on tunneling. Modern electronics like flash memory depend on it. Without tunneling, much of the technology we use wouldn't work. And yet, we still don't fully understand why it happens. It's a reminder that the quantum realm doesn't care about our rules. It dances to probability, to wave functions, to uncertainty. Quantum tunneling invites us to rethink what's possible, that maybe, even when something looks like a dead end, the universe still allows a way through. Number 39. The Drake equation, calculating cosmic company. How many intelligent civilizations are out there in the vast silence of space? That's the question the Drake equation tries to answer, not with certainty, but with curiosity structured as math. Developed by Frank Drake in 1961, the equation multiplies a series of factors: the rate of star formation, the fraction of stars with planets, the number of planets that might support life, the chance life arises, the chance it becomes intelligent, and the lifespan of such civilizations. Each variable is uncertain. Some we now estimate better than ever, like the fact that most stars have planets. Others, like the probability of life evolving, we still don't know. But that's not the point. The equation doesn't give a final number. It gives us a framework to think about possibility. Depending on what numbers you plug in, the result could be 1 or millions. Either answer is staggering. If we're alone, it means life is rare, precious, maybe unique. If we're not, it means we share this galaxy with other thinking beings, looking up at their own skies. The Drake equation doesn't solve the mystery. It invites us to explore it, because sometimes asking the right question is its own kind of answer. Number 40. The Poincaré conjecture, solved or still mysterious. For a century, the Poincaré conjecture stood as one of the most elusive problems in mathematics. Proposed in 1904 by Henri Poincaré, It asked a deceptively simple question. If a three-dimensional shape has no holes like a stretched-out sphere, can it always be transformed into a sphere without cutting or tearing? In higher dimensions, mathematicians had solved similar problems. But in 3 dimensions, the space we actually live in, the answer remained uncertain. That is, until 2003, when a quiet Russian mathematician named Grigory Perelman published a proof. It was dense, abstract, and brilliant. Perelman's work didn't just solve the conjecture, it reshaped how we understand the structure of space itself. The Clay Mathematics Institute had offered $1 million prize for the solution. Perelman declined both the award and the fame. He disappeared from public life. So, is it solved? Mathematically, yes, but philosophically, the mystery lingers. What does it mean for space to be curved without being visibly so? What does it tell us about the shape of the universe? The Poincaré conjecture reminds us that reality isn't always visible. It's hidden in forms, functions, and folds. And sometimes, even the simplest sounding questions open up the deepest mysteries. Number 41. The existence of life's origins, abiogenesis versus panspermia. Where did life come from? Not life as it is now, but that very first spark, that moment when chemicals stopped being random and began to replicate, adapt, evolve. There are 2 dominant theories, abiogenesis and panspermia. Abiogenesis suggests that life emerged right here on Earth, that in some warm little pond, a mix of organic molecules self-organized purely through chemistry and chance. Over time, simple molecules became complex, chains formed, cells took shape, life began. Panspermia, on the other hand, proposes that life, or the ingredients for it, came from elsewhere, perhaps inside asteroids, or frozen in comets, carried across the cosmos. If this is true, Earth isn't the cradle, it's the recipient. Neither theory is fully proven. Abiogenesis is more grounded in Earth's chemistry, but the conditions required are rare and not yet fully replicated in labs. Panspermia, meanwhile, just shifts the question outward. If life came from space, where did it start? Both ideas challenge us. They ask us to reimagine life not as a miracle, but as a process, one that might happen more often than we think. Maybe life didn't need magic, just time, energy, and the right cosmic ingredients. Number 42. The baryon asymmetry. Why is there more matter than antimatter? According to physics, matter and antimatter should have been created in equal amounts during the Big Bang. But look around the stars, the planets, even you are all made of matter. So, where did the antimatter go? That's the puzzle of baryon asymmetry. Antimatter isn't imaginary, it's real, and when it meets regular matter, the two annihilate in a burst of energy. So if both were made equally, they should have wiped each other out, leaving only light. Yet here we are in a universe of something rather than nothing. This imbalance defies the known laws of physics. Something tipped the scales, just slightly, early on. Maybe some unknown force or decay pattern favored matter. Maybe a slight violation of symmetry laws allowed matter to win. Physicists have looked for answers in particle accelerators, in cosmic background radiation, in rare subatomic behaviors. And while hints exist, no single explanation has emerged. The fact that you exist at all means something broke the balance, and that tiny asymmetry gave birth to everything. Number 43. The quantum Zeno effect, stopping the passage of time. In quantum mechanics, observing a system changes it, but what happens if you observe something constantly over and over again in rapid succession? That's the question behind the quantum Zeno effect, a phenomenon where frequent observation can prevent a system from evolving. It sounds like a paradox, but experiments have shown it's real. In simple terms, if you measure a quantum particle often enough, you can freeze its state. Like a watched pot that never boils, not just metaphorically, but literally. This happens because in quantum physics, particles exist in a state of probability. When you measure them, you collapse that probability into a fixed outcome. And if you keep collapsing it quickly enough, the particle can't change. It's stuck in a kind of suspended animation. This effect challenges how we think about time and causality. Can observation halt change? Can watching something closely enough actually prevent it from becoming something new? In a strange way, the quantum Zeno effect reminds us that presence, even passive, has power, and that sometimes things only move when we stop looking. Number 44. Cosmic inflation, the early exponential expansion of the universe. In the first trillionth of a second after the Big Bang, the universe didn't just grow, it exploded outward faster than the speed of light. That's the idea behind cosmic inflation, a theory that explains how the early universe expanded at an unimaginable rate. Before inflation, everything was dense, hot, and quantum fluctuating. Then, for a fleeting instant, something triggered exponential growth. The universe expanded from subatomic size to something galactic in scale in a blink. This rapid inflation solves many cosmic puzzles. Why is the universe so uniform? Why does it look flat rather than curved? Why do distant regions of space seem synchronized, even though light hasn't had time to travel between them? Inflation provides elegant answers. But the mechanism behind inflation, what caused it, what stopped it, remains mysterious. Some physicists believe inflation never really ended, that we're in one bubble of an ever-growing multiverse. Cosmic inflation reminds us that the universe didn't just begin, it surged. And from that unimaginable expansion came everything we now call home. Number 45. The Briggs-Rauscher reaction, the chemical clock mystery. In most chemical reactions, things happen once. A change of color, a release of heat, the formation of something new, and then it's over. But not here. The Briggs-Rauscher reaction is a chemical clock, a swirling, color-changing loop that seems almost alive. Mix a few simple ingredients, and suddenly the solution oscillates between clear, amber, and dark blue over and over again. It doesn't just react, it cycles, rhythmic, predictable, and completely mesmerizing. It defies expectations because the system appears to remember and repeat. What's happening beneath the surface is a delicate dance of chemical concentrations. As one set of molecules builds up, it triggers the next phase, which triggers the next until the original conditions reset and the process begins again. It's not magic, but it certainly feels like it. Scientists have studied this reaction, not just for its beauty, but for what it suggests about complex systems. How feedback loops can create patterns, how order can emerge from chaos. and how even lifeless chemicals can look eerily like living processes. The Briggs-Rauscher reaction doesn't last forever, but for a brief, glowing moment, it feels like time made visible. Number 46. The Great Filter. What stops civilizations from advancing? If the universe is full of stars, and many of them have planets, and some of those planets could support life, then where is everybody? That's the heart of the Great Filter. The idea that somewhere along the path from simple matter to intelligent life, something stops civilizations from progressing. The filter could be behind us, meaning life is incredibly rare, and we've already survived the hardest part. Maybe it's consciousness, or complex cells, or language, or the filter could lie ahead. Maybe most civilizations destroy themselves through war, environmental collapse, or runaway technology. The concept is chilling because if the filter is in front of us, it means most advanced species don't make it much farther. It turns the silence of the stars into a kind of warning. But there's also hope in the idea. If we are rare, if we've already passed through the narrow gate, then our existence becomes even more precious. We are the exception, and our survival matters more than ever. The Great Filter doesn't answer the question, but it makes us ask, what kind of future are we building? Number 47. The Kardashev scale, measuring technological advancement. Not all civilizations are created equal. Some might barely harness fire, others might control stars. That's the idea behind the Kardashev scale, a way to measure a civilization's advancement based on its energy use. Proposed by Russian astrophysicist Nikolai Kardashev, the scale has three main types. Type I, a civilization that uses all the energy available on its home planet. Type 2, one that harnesses the full power of its star, perhaps using megastructures like Dyson spheres. Type 3, a civilization that controls the energy output of an entire galaxy. Humanity? We're not even at Type I yet. Some estimate we're around 0.73, but we're climbing, slowly. The scale isn't just about energy, it's about imagination. It challenges us to think beyond our limits, to ask what civilizations might look like after millions of years, to wonder whether aliens, if they exist, would even bother talking to a species still dependent on fossil fuels. The Kardashev scale isn't a scoreboard. It's a map showing just how far we might go, if we last long enough to get there. Number 48. The EAT theory, a surprising potential for a toe. In the quest to unify physics to find one elegant theory that explains everything, many paths have been proposed. One of the most surprising? The theory. E8 is a mathematical structure. It's a shape not in space, but in symmetry. It exists in 248 dimensions, with intricate interconnections more complex than anything we can visualize. For decades, it lived quietly in the world of abstract math, until physicist Garrett Lisi suggested it might describe all the fundamental particles and forces in the universe. He proposed that each particle could be mapped to a point on this structure, like fitting the universe into a single, symmetrical blueprint. The idea was bold, beautiful, and controversial. Critics say it's incomplete, more poetic than proven. Still, the rate theory represents something profound, that maybe, deep beneath reality's surface, everything is shaped by symmetry, that the universe isn't just chaotic, but choreographed. Even if E8 isn't the final answer, it reminds us that beauty matters in science. And sometimes, truth hides in elegant patterns we've only begun to understand. Number 49. The nocebo effect. Harm from harmless things. You've likely heard of the placebo effect healing triggered by belief. But what if belief could do the opposite? What if thinking something would harm you actually made you sick? That's the nocebo effect, when negative expectations cause real symptoms, even if there's no true danger. Take a sugar pill, but believe it's poison, and you might feel dizzy, nauseous, anxious. Reported side effects rise when patients are warned about them, even when given inactive treatments. This isn't imagination. Brain scans show real changes: pain, fatigue, inflammation, all triggered by belief alone. The nocebo effect is a reminder of how deeply the mind and body are connected. Words matter. Expectation shapes experience. And fear, even if unfounded, can become its own kind of illness. Doctors struggle with this paradox. How do you warn someone about side effects without making them more likely? And in everyday life, how much of our suffering is amplified by what we believe will hurt us? The nocebo isn't just a medical oddity. It's a quiet warning that thoughts, when left unchecked, can become physical truths. Number 50. The end of the universe. Different scenarios of the cosmic conclusion. All things end, even the universe. But how it ends, that's still unknown. Physicists have imagined several possibilities, each one vast, strange, and final. This is the mystery of the end of the universe. One scenario is the Big Freeze. The universe keeps expanding, galaxies drift apart, stars burn out, and everything goes dark. No energy, no light, just cold emptiness. Another is the Big Crunch. Gravity reverses the expansion. Everything collapses inward. Galaxies, stars, atoms, crushed back into a singularity, like rewinding the Big Bang. Then there's the Big Rip. If dark energy grows stronger, it could tear apart galaxies, solar systems, even atoms. The universe wouldn't just fade, it would be ripped from the inside out. There are even stranger ideas: heat, death, vacuum decay, cyclic models where endings give rise to new beginnings. Each version tells a different story, a different shape to the final breath of time. No one knows which will happen, but each ending invites a question. What do we do with the time we have now?